right, I'm going to do two hypothesis tests for two sample proportions just because I think they're a little bit ugly and this one's a little bit different than the others. So tumbleweed, commonly found in the western United States, is a dried structure of certain plants that are blown by the wind. Cochea is a type of plant that turns into tumbleweed at the end of the summer and is a problem for farmers because it takes nutrients away from soil that would otherwise go to more beneficial plants. Scientists are concerned that cochea plants are becoming resistant to the most commonly used herbicide, glyphosate. In 2014, 19.7% of 61 randomly selected cochea plants were resistant to glyphosate. I'm going to go ahead and write that down. So 2014, we had 19.7, that's our p hat, and we had out of 61. In 2017, we had 38.5%, so this is our p hat, out of 52 be resistant to glyphosate. Do the data provide convincing statistical evidence at the level of 0.05 that there has been an increase in the proportion of all cochea plants that are resistant? So they're asking whether or not 2014 is less than 2017 or that 2017 is greater than 2014, depending on how you define your parameter. All right. And by the way, when they ask for evidence, they really are looking for you to run a hypothesis test as opposed to a confidence interval. So P1 equals P2, and P1 is less than P2. And I'm defining P1 as 2014 and this as 2017. So P1 equals the true population proportion of cochea plants that are glyphosate resistant in 2014. And P2, the true population proportion of cochea plants that are glyphosate resistant in 2017. Conditions: two random samples are given. One sample of 64 and one sample of 52. You don't need to list that. You can just put that part right there and you're good to go. Samples are independent. I'm not sure that they are. It's reasonable to assume that the resistance of the sample plants taken in 2017 was not influenced by that in 2014. I'm not sure that that's the case because they say they're becoming resistant, so they are changing, but it is what it is. We're still going to run the test. All right, I need to check well, first off, I can do this real quickly. The N is less than 10%. Well, 61, I'm sure that there's more than 610 cochea plants in 2014, N is less than 10%. And over here, I'm sure that there's more than 520 in 2017, especially if they're becoming less resistant. Now, this isn't showing up here, and that's going to be important for us real quickly. So I need to calculate whether or not we're going to meet the normality condition. To do that, I actually have to combine the two samples. Well, that's kind of a problem because of the way this is set up. We ended up with 0.197, and when I do that, because I don't have an X value, so we're going to go 61 times 0.197, and that's where my 12 comes, and we're going to have to round. So this first value up here is 12. And then over here, I'm going to have to do the same thing, except it's going to be 52 times the percentage, which is about 20. And once again, we're going to round. And the reason we're rounding is a calculator will only work with whole numbers. And so that will give me, this will give me my p hat C. Now the calculator will do that for me. And so I'm going to go ahead and run the test and then come back up here and do that. I know that's a little bit out of order, but kind of eliminates a lot of errors. So here we go. We're running a two proportion z-test. And we're looking for x1. Well, they didn't give us x1. That's what we just calculated. We want 61 times 0.197. Well, it calculated that at 12.017. Don't leave it that way. It has to be a whole number. And so that was 12 out of the 61. And over here, we had 52, and we go 52 times 0.385, and it gives us 20.02. If you leave it as 20.02, it's going to give you an error, and you're not going to know where it is. So round it to the closest number, which in this case is 20. And in this case, we had a sample size of 52. And this was a less than symbol, so I need to make sure that I have a less than symbol there. And if I look down, I see, oh, there's my p hat. That's my p hat. That's not my p. That's my p hat C right there. That's 0.2831. And that's what I need. That came from the calculator. That's what I need to check normality. So 61 times that and 61 times 1 minus that. When I did that, I got both times I got numbers greater than 10. When I multiplied by 52, I got numbers both greater than 10. So because I had that, both samples are large enough to use a normal approximation. So I haven't written down the name of the test, so I've just done that. The two sample z-test for proportions, got to write that down. And I've got to plug in all that information. There's that 0.97197 from 2014. And the 0.385 from 2017. And so I have everything plugged in. I'll make sure I write down my z-score. I also write down my p-value. Well, that's a pretty small p-value, and with a p-value like that, we're going to reject the null. So our p-value is 0.0135. We reject the null. There is enough evidence to suggest that the true population proportion of cachea plants that are glyphosate resistant is less than 2017. It appears that the cachea plants are becoming more glyphosate resistant. All right, that takes care of that one.